do me a favor, do not, listen, do not write these down. I want to briefly go over, there's 5 theorems. We're not going to deal with the theorems as much today. We're going to deal with the problems that come from them. But I want you to understand that a theorem is a shortcut. It's something that we could actually take the time to prove is true, using definitions, postulates, other things. A theorem just makes it so that we no longer have to do 2 or 3 steps to get to that. It's important to know the theorems. Today, you don't need them, but I wanted to briefly go over it and show you that a theorem is something that we could actually prove to be true. And the first theorem says vertical angles are congruent. We've already talked about that. All vertical angles have equal measurements. And I can show you that angle 1 has to be congruent to angle 3 without using this theorem. Can anybody tell me what the measure of angle 1 plus the measure of angle 2 would have to be equal to, and why? Angle 1 and angle 2 have to be equal to what? 180. And I know that that is the definition of a linear pair. Likewise, I could say that the measure of angle 2 plus the measure of angle 3 was equal to 180 degrees. It just forms a different line. Does everybody see that? Because these are both equal to 180, I can now write this. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 by substituting that in. Where this 180 was, I simply replaced it with angle 2 and angle 3. Everybody see what I did there? What would happen if I subtracted the measure of angle 2 from both sides? What's going to be left? The measure of angle 1 equals the measure of angle 3. And this would be the subtraction property of equality. So, they tell me that all vertical angles are congruent through this theorem. But do I really need the theorem? Or could I do it a different way? I could do it in 3 steps. I could get there. I could show you that they're equal. They're going to be equal every time because of that. A theorem is simply something that we could take the time and prove individually, step by step. Again, I don't want you to write these down, but I want you to see them. Congruent supplement theorem says if 2 angles are supplementary to the same angle, angle 1 and angle 3 are supplements, angle 2 and angle 3 are supplements. 1 and 2 are supplementary to 3. If you have 2 different angles supplementary to the same angle, then those 2 angles are equal in measurement. 1 is going to be congruent to angle 2. The same holds true if they're complementary to the same angle. You notice that 1 and 2 are complements. 3 and 2 are complements. So 1 and 3 are congruent to each other. 2, 4 hopefully goes without really saying that much. What do we know about all right angles? They're 90 degrees, so all right angles are congruent. The last one, again, to me, kind of makes common sense. If 2 angles are congruent, in other words, angle 1 and angle 2 are congruent, and they're supplementary, which means that angle 1 plus angle 2 have to add up to 180 degrees. What does that mean about angle 1 and angle 2? They're 90 degrees. They both have to be equal, so they both have to be 90 degrees. Okay? Now, that gives you a brief idea of where this chapter is going, but here's what we're going to work on today. And all these examples look pretty much the same. So go ahead and write the two examples that you see down. Where they've put the information in this picture, what type of angles are these two angles? They're vertical. And what do we know about all vertical angles? What are they? Congruent, or they're equal in measurement. So I know that 6x must be equal to 2x plus 24. And if I wanted to put a reason beside it, vertical angles are congruent. What would I do next to solve this? That would be the reason, the subtraction property of equality. What am I going to subtract? Technically, I'm subtracting the 2x. It would bring me to 4x equals 24. And what would be the next thing that I'd want to do? So the division property of equality, I'm technically dividing both sides by 4, would bring me to x equals 6. Now, we've been used to doing this side, basically just the statements. But if I wanted to turn this into a proof, what did I provide over here? The reason that I could do it. All things that you actually do, you kind of do it mentally. You don't think about it. But if you ask yourself, how do I get from here to here? Put that on the reason side first. It just makes a proof flow better. In example 2, what type of angles are in the picture? What are they? They're vertical, so what do I know about them? They're congruent, or they're equal in measurement. So 17 plus 3x must be equal to a negative 4x plus 31. By the way, my next step and your next step could be different at this point. The first step would have to be the same in order to get it set up. What do you think I'm going to do next? I'm actually going to use the addition property. What am I going to add? I'm going to add 4x to both sides. But you could have subtracted. It would have been okay. 17 plus 7x equals 31. What would I do next? I would subtract the 17. I'd have 7x is equal to 14. And what would my last step be? Divide by 7. Now, does everybody see that even though we didn't write the reason beside it, we talked about the reason as we were doing it? So the reason that you'd normally put here, you actually have been processing it right along. It's just that in a proof, they're asking you to actually write that piece of the puzzle in there now. Everybody good with example 1 and example 2? I want you to do example 3 on your own. Let's put back up. In example 4, these two angles are still what type of angles? They're vertical. So if I take 2x plus 24 and set it equal to 2x plus 24. And I can do that because they are vertical angles. I like to get my x's on one side first. So if I subtract 2x from both sides, I end up with 24 equals 24. Is there an x left in my equation? No. So there's only one of two possibilities when the x completely drops out. There's either no solution or it's all real numbers. Because this is true, 24 is equal to 24, this one would be all real numbers. Questions on example 3 or example 4? Yep.
Okay. When exactly would it be no solution?
If it came out, let's say that they changed this number to 20. Okay? Then this would say 20 equals 24. Is that true or false? That would be false, right? 20 doesn't equal 24, right? And then there would be no solution or an empty set. So when the x's go away, it's either going to make a true statement or a false statement. If it makes a true statement, you get this, all real numbers. If it makes a false statement, you get this, no solution. Everybody good with that? Okay. I'm going to give you a few seconds to copy this example down then. Because here we're talking about how to prove that angle 3 is congruent to angle 7. And they give us this, and it's kind of a complicated looking picture, but none of this is really difficult. Okay. First off, for this first statement, the first statement usually comes from what they've given us. So the first statement is going to state that angle 6 is congruent to angle 2. And the reason is that they gave it to me. Please, if you do one thing, make sure that you do this. If they give you information about a picture, and it's not marked in the picture, mark it in the picture. Angle 6 is congruent to angle 2. So you notice I put that little curve mark on angle 2 and angle 6, showing that those two are in fact the same. If they give you information about a picture, put that information into your picture. It's going to help you work it out in the end. The next statement that they made said angle 2 is congruent to angle 3. Well, angle 2 has 1 mark on it. To make angle 3 congruent to it, I'm going to mark it with 1 mark as well. Why do I know that angle 2 and angle 3 are congruent? They're vertical angles. And all vertical angles are congruent. Now, the next step, they gave all of it to us, but it is one that I always like to talk about. Notice that they said it's going to be the transitive property. Notice that where statement 1 stopped, statement 2 started. Does everybody see that? So in statement 3, they started with 1 and they ended on 2. So angle 6 is congruent to angle 2. Angle 2 is congruent to angle 3. So they could state that angle 6 is congruent to angle 3. And this is the transitive property. Remember, the transitive property says if A equals B, B equals C, then A equals C. Where this stops, this starts, so I can go from the beginning all the way to the end. What other property might I have used here that would also work, but this one's better? Does anybody know? You used it in your assignment last night, or a week ago, I should say. Substitution would work, but transitive is the better choice in this case. So, I'm going to mark angle 6 is congruent to angle 3. It's already marked. You can see they both have 1 mark on it. The next statement says angle 6 is congruent to angle 7. Angle 6 has 1 mark on it, so I'm going to put 1 mark on angle 7. Why do I know 6 and 7 are congruent? They're vertical angles. Now, on number 5, notice this one said 6 to 3, this one said 6 to 7. Did this one stop where this one started? So I can't use the transitive property this time. What do I have to use? Somebody say it. You used it last night. Well, you should have used transitive. What's the other property? Substitution. Everybody good with what's there? Go back. Yep. Okay.
On number 5.
Yes.
So, like, what's the difference between 5
And 3?
yeah?
Okay. If you look at number 3, this said 6 and 2. Where this stopped, this one what? Started. Where this stopped, did this one start there? No. In fact, they both started with the same thing. The transitive property has to be in this order. Where the first statement stops, the second one has to start. Since it didn't do that, I'm left using substitution. Okay? Do you see the difference? Okay. Please do not copy this example. I simply want to talk about a mistake that's in this proof. I mean, we could fill in all the pieces, but I'm going to tell you the mistake is right there. And it's not that x isn't 10. Does anybody know why that would be a mistake and why I'd want to point it out? This really should have one more statement in it. There should be a statement 9, and it should say x equals 10, and it should be this way because that is exactly what they're asking me to prove. What property allows me to go from 10 equals x to x equals 10? It is the symmetric property of equality. Okay? I just wanted you to see that if they're asking you to prove something, that whatever your last statement is, this would be wrong because I haven't proven what they've asked me to prove. So your assignment today is out of your workbook. If you want to go up and pick it up, it's out of 2-6. It's page 55 and 56. And you're going to do 1 through 12.